right. Yeah, recording has started. So basically, like I said, I'm just going to share my screen now. You guys can see my screen, please let me know. Yeah, I'm going to do the intro to the library while Tosin will take over from wherever I stop. Yeah. Can you guys see my screen?
Yes.
All right, good. So now over to documentation. Is a quick guide towards working with Matplotlib Python visualization library. Over here, you can see a line graph. Doesn't look very nice, but it's not well detailed either. But basically, with Matplotlib, you can make such visualizations. There are this is referred to as a scatter plot. So we're going to be looking at how to create scatter plots and then color them based on anything we want, really. There's also, this is still the line graph. This is a scatter plot with, this is a line graph rather, with markers. So you can put different types of markers, whether you want it to be O's or X's or plus or whatever, star signs, anything. This is also line graph plots with different styles. And say these are broken lines and these are dotted lines or what have you. Still scatter graph. Now, basically, when it comes to Matplotlib, right, there are two styles of working with the library. You look at this, you see plot.fig, plot.fig, sorry, plt.plot, and then you look here, you see ax.plot after first declaring this. So the two styles are explicit and implicit. I prefer to use the implicit because the library handles all of this. I don't have to bother about, you know, creating two variables and assigning it to whatever I want to achieve. So we're going to be working with the implicit style today. Look at here. It says explicit creates figures and axes. That's fig and ax and call method on them. While for the implicit, right, you just have to say what you want to do. And Matplotlib is going to understand that, okay, this is what it's trying to achieve. So I'm just going to take care of every other, whatever that has to be done under the hood. So I don't have to see all of that. Over to this. I'm just going to comment this out. I'm still going to uncomment that, but for now, let's comment it out. Now, when you want to Matplotlib, you have to import it. You can either do from, if you know how libraries work, right, and packages basically, you can either import the library. You can either import the entire library, right, which is this style, import matplotlib. Then from here, you can now call the class or whatever that you want, which would be pyplot. Pyplot is the, I call it the class? Yeah, basically from matplotlib that allows us to plot. So you can either import it as import matplotlib.pyplot. It's already coming up for me here as PLT. This is the standard way or the standard alias that is assigned to Matplotlib in Beta World. Or you can simply do the from, you can import the specific thing you want. This is importing everything and then calling the specific one you want. Or you can import the specific thing. You say from here, give me this. So now we're going to say from Matplotlib, give me or import just pyplot as PLT. So whichever style you choose, eventually you just need to understand how to arrange your function and what you are saying, or your import statement rather. So now I'm going to remove all of these and go back to what we initially had. On this, yeah, I'm just importing this data because we are going to be using this to visualize on my end before moving on to Tosin's end. To make a visualization, you simply just do plt dot dot. Let's look at the options that we have initially. See, you can get a bar plot. We know what bar plots are. Those are the box line plots. Basically, this is, where's that? This is a histogram, not a bar plot. Histograms have every single thing joined together. You can see them closely joined, right? For bar plots, they are separated. Yeah, this is a bar plot. See, bar, separated bars. Each bar is independent of the other. Then, I'll see if I'll see. I'll already show you guys a histogram. So basically, with matplotlib, we can have several kind of plots, be it line plots, bar plots, whatever. I'm going to start today with, let's create an array of whatever we want to represent. So as we know, histograms, right? They are plots of frequency. So a histogram is going to plot the amount of whatever you give it to it that exists. Let's say we have this list now. In a histogram, right? You don't need let me just start first so you understand what I mean. So our x is going to be equals to 1, 2, 1, 6, 8, 9, right? While our y is going to be, our x basically is the things that are going to be on the x side of our plots, while the y is the y axis. So for our y now, let's just have sorry, give me a few seconds. I need to get something. Sorry, I need to quickly do something, so I'm just going to stop sharing my screen for a few seconds. All right, sorry for that. Yeah, back now. So I'm guessing my screen is visible again. Yeah, we come back here. Then I want let me put in things like, let's use the same, let's just copy the same array. See what it look like. So now I want to make a bar plot of these with the x values to be this and the y values to be the same. What I'm going to do now is I'm going to do plt dot, you call bar, and you pass in, you see here, x, an array, and then the heights, which is our y. Passing my x here, let me just write down x, comma, and the heights y. If I run it like this now, I'm going to see my plot, but this is not the right way to do things, because you see this coming up here, bar container object of 5, whatever. You don't want to see that when you're making your plots. How to get rid of that is by simply calling plt.show, which is telling the library, all right, so I've put what I want, now show me my plot. You see that this is quite ugly right now, but I mean, we're still going to adjust some few parameters here to make things look better. Now, obviously, at times when you're plotting, or most times, all the time, basically, you're going to have the x-axis name, your y-axis name, and your plot is going to have a title. So how do we go about putting all of those information into this? Simple. Come here, plt dot x label. You see this? Meaning what the name of my x-axis should be whatever I pass into this. I'm just going to call this ages. When I rerun that, you see that the x-axis now has the label ages. So if assuming I want to give this here a name, who can tell me what I'm going to do? This is my what axis, and what do I do to give it a name? So whatever name you want to give it, let's just have it any random name, anyone. Real one, your hand is up. So what do we do?
So the PLT dot y label.
All right, I didn't get that.
PLT dot y label.
All right, plt dot y label. And since this is real one that gave us that, let's just call it real one. All right. Now at the top of your plot is what you call the title. So in order to give your plot the title, we're still going to look into, how to make this bigger, because right now we can't really, it might not be very clear to us that, okay, this is a real one written here and this is ages. So we can increase our font size, but for now, let us handle the title by simply doing plt.title, and you pass in for this our plot. So that is how this is the basic or the fundamental step of creating a plot and naming your axis and your title. Now, we want our title, right, to be outstanding, because obviously it is title, it is what you capture your attention at first. So how we do that is by passing in a font size, just like our Microsoft Word and all of that. So you pass in the font size and just give the font size of 20. Let's see what that does. Let me made a mistake here. Font size. Yeah. So now we see that our title, or our title text rather, has a font size of 20. So you can always play with that. I don't know, whatever you feel is suitable for you, you can play with that. Let's give our X and Y labels font size of, let's say, 15 or 10. Let's copy this here. Run that. Okay, this is too tiny. So I'm going to make this 25 and make this like 15. We have something that looks a bit better. Now let's say we want to increase the size of this plot. This plot is what's referred to as, you see, we have and go back to documentation, you see figure. So basically our entire plot is referred to as a figure. Now we want to adjust the size, that is the length and breadth of our figure, right? So I'm going to come here. How to do that? I think I have to place it before this here. So I do plt.figure, meaning for the figure, give me a figure. You see it here, you see the parameter. Give me a figure size of, and you pass your X and Y size, whatever you want. Let me just experiment. Let's see, 10 by 10. You see, we have a 10 by 10 figure size. What happens if I place this here. Let me see if anything will go wrong. I don't think because it's not a subplot. Okay, yeah, something did go wrong. So basically, right, we say plt.bar, meaning give us a bar plot. Then we're now calling plt.figure for what we've already plotted. So basically it's going to give us a figure with that size that we specified. But that figure is not going to be linked to this because we call this after we have already plotted our graph. So you have to be cautious of the position, because on the long run, when you're building let's say you're performing a very, very advanced EDA, right? That's exploratory data analysis, and you have to plot like several plots side by side, side by side. Those kind of plots, they are called subplots. So basically, they are subs of a major plot. So you can make like, let's look at what subplots are here. So you can get what I'm saying. These are two plots, right? But they are basically subplots. They are subplots, yes. Meaning that 1 and 2. Not like there's one plot, right, with one section of code, then another. They are basically in the same area, making them a subplot. So when we're going to get to subplots later on using the implicit method, not the explicit. Let's go back here, adjust this bar, right? Doesn't really look so great. So let's adjust the y-axis value. Remember what I said before, this is x, y, 0, 1, however you want to look at it. Let's make this something like 7, see what happens. Yeah, it looks much better than before. So another interesting thing we can do is, let me convert this from bar to scatter. See this? This is what is referred to as a scatter plot, meaning it is a plot with basically scattered dots. The reason why this is a linear graph is because we have linear values here, where our x is equals to our y. So that this is the only reason why it's a straight line graph. Sometimes when you're working with data, right, you can have different kind. You just see dot 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 everywhere, and you don't really know which is which, or like the difference between those whatever dots are on your screen. Now, how to identify or differentiate between those kind of dots is something we call our hue, or the color. Then you can tell the matplotlib, right? Okay, for our data set, now let's import this data set data. You guys remember what data.head does for us, right? To automatically give us the first 5 values. Let's say we want to plot something like let's say number of stops and duration. Let's try that. Show you guys what it looks like, what a more scattered plots will look like. So plt or scatter, we pass in our data stops, so x, and that's our y, we pass in our data. Then we call our show. See what this looks like. This is also linear because everything is something random. I'm going to use numpy as np, and x is going to be equals to np dot a range. we want, what I'm going to specify here, right, is the dimension of the data. So np.random is going to give me random numbers, right? And I want the dimension to be a 1 by, say, 100 random values. Should correct. I'm supposed to pass this directly. Let's see what our x is. I'm going to plot, let's reduce this size. Let's make it 40. And then we generate our y, which is going to be equal to np dot another random set of values around n, 40, because we have to have 40x and y values. I'm going to plot plt dot scatter x and y show. This is small. Let's make it 80. You can see how this scatter plot, right, is really looking very not organized. When you have data, right, you can have, and you can visualize them in various kinds of ways. Yeah, this looks more like it. We have a scatter plot now. Normally, right, what you have is you can have like a very from when you look at this, can you really understand what this is trying to tell you? You can't make anything out of this, right? But let's say now there's a famous data set, what's it called, the iris data set, right? You guys are going to work on that. Basically, you're going to determine the species of an iris plant. So now, if we have this kind of data, let's say we are plotting the length times the breadth of the petals of the plant, right? Now we can make a hue or difference in the color of what kind of species. We can say that, okay, for the first species, right, give it the color of black. For the second species, give the color of green, and the other species give the color of red. Now, what that's going to do for us is that it's going to separate them. Instead of just seeing plain blue, you can now see maybe from here to here is going to be blue, these ones will be black, these ones will be red. We can now tell that, okay, when we look at it, we can see that, okay, so basically this species of plants, they have like smaller petals or sepals or whatever. Basically, we're going to get to that point. So I'm just kind of throwing you random stuff at this point for you guys to kind of understand. Let's draw a line plot. This is plt dot plot alone is going to give us a line plot. So we're going to see a straight line now and increase. Let's do comma s, right? S size. So just again. I'm trying to adjust the size of this ball. That's not the right parameter. I'm going to figure out the right parameter later and kind of show it to you guys. So for now, I'm just going to let Tosin take over while I we discover what is PLT, please. PLT, as we imported here, PLT is our alias for the pie plots from matplotlib library, right? Does that answer your question? So PLT is basically what assists us to make our various kinds of plots. Here we see we use PLT to make a scatter plot, meaning just dots, dot, 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 dot. We use PLT to make a line plot, which is our basic PLT dot plots. Then we can also use PLT to make bar plots, histograms, and whatnot. So Tosin, are you here? You still with us? Tosi.
Yes, I'm here. I'm here.
All right, sorry. You can
Can you hear me?
take over. Yeah, I can hear you. Can hear you now.
Okay. Okay. Okay.
Yeah.
I'm coming.
All right.
Yeah. Okay. So let me share my screen. And
Yeah.
go from there. Mhm. Can you see my screen?
Yeah, we can see your screen now.
Okay. Okay. I'm coming. Let me just close up all of this. Um. Sorry. Mhm. Yeah. Okay. Okay. So as he has been saying, I was like, I will talk after like questioning a lot of points he has made from here. First of all, when it was, I think the first thing he introduced was the idea of like PLT, figure and axis and everything. And I want to know that you can sort of see figures like a blank canvas, yet like a blank canvas to I can just like walk on and everything and see artists that the plot itself. And now another thing he said was when he was talking about title. In some cases, yeah, you have like I think it's also called axis or title, so you can give a particular axis. As I said, it figure is the blank canvas, and this thing axis are kind of like the plotting, so you can have like multiple plots in one, and you can get each of those plots titles on their own. With I think the axe dot title will do that. Give each of those plots their title and everything like that. Then apart from the idea of like a title, PLT dot title, that's the title for the whole figure. I think you can also have something like PLT dot super title. So it comes from the idea of let's say you have a like major title, or let's say you have a large figure, you want to have a title at a particular point, a title at another particular point. So you have like multiple axes, kind of like if you have a whole canvas, from top to the middle, you are making some certain plots and give the title, and from the middle to the bottom, you have another set of plots, and you want to give that a title too. So you can give everything on the canvas a title with, I think, PLT the super title. I think that will do it. Then what else? Yeah, I remember some points I wanted to raise when I was in school. Okay, also, in most cases, we're not going to be using like matplotlib as this. Matplotlib is mostly used as a let's say a base this thing, and the most almost we end up using is another library called Seaborn. But it's still important to like know at least the basics of matplotlib because Seaborn builds on what matplotlib does. Matplotlib is not that flexible and does not have that kind of like wild range of what you can do with it. But Seaborn just like is a library on top of matplotlib that just like builds everything wider and everything like that. So that's for that. Also, in some cases, you might want to save a. I think at particular point, I was to get to this thing. I was to get um Jupyter notebook. You guys can see my screen, right?
Yeah, yeah.
Hello. Yeah. Okay.
Yeah, we can see your
Okay. That's
screen.
good. Yeah. Upload. But it's. I mean, I want to see where I save it to. Should I save it in the right place? No. I didn't. I'm coming. Sorry.
Yeah, no problem.
Hmm. Hmm. Okay. Mm. Yeah. Okay. Um, import market perspective. Sure. Yeah. You are good to go. Let me also import Panda so I can get in the data. Data. That's fine directly. And so let me stop sharing my screen for a while. I want to get data. Yeah, you can.
So while he's trying to get his data, I just wanted to share something. I just kind of remembered. All right, so when I imported the data set, right, the first thing I wanted to show you guys was how a histogram works. We already know what scatter plots are, and basically bar plots are like, what's that? I think we had our bar plots here before. So for a histogram, right, histogram plots frequencies, meaning we do not have to pass in our x and y variables. We just need to pass in an x. Then from there to now decipher, okay, oh, so let's say we pass in our arrival time, right? It's going to count how many nights there are. It's going to make that one of the y variables, and under that y is going to be the frequency of the nights. So let's look at what that looks like right now. Into the plt dot hist. Hist is what we call when we want to plot our histograms. Then we're going to do data. Another way of calling out columns from a data frame, right, is by using dot. If I do dot, I do this now, arrival underscore time. I show this plt dot show, right? I'm look at this now. You see your nights. Basically, what it did here is that it got all the different arrival times, and it counted how many nights they are, how many mornings they are, how many early mornings, how many afternoons, and then it now give us the frequency on our histogram. I'm going to increase the size of this plt dot figure, and then click size is equal to, before we use 7,10, and we'll use 10,7. And on the x and on the y, we need 7 here. So right now, there's an issue with this plot, right? If you look over here, you might not be able to tell, okay, well, this is the highest that this can get to. So we can increase the value. We can alter the value where we start from and end at with using the x lim, which stands for, so using the y lim, because we are talking about y axis. You increase the y limit by doing this plt dot y limit. Now I want to set the y limit, the minimum. Let's use this is 20k. So I'm going to use 20k. When you're coding, right, if you want your values to be clear, you can use underscore to separate them. So this is, the interpreter can tell that this is 20,000. So in case you're typing a very large number and you want to be sure that you're getting the commas where they're supposed to be, you can do this. So I do 20k, and then let me put this, instead of stopping at 80k, Let's stop at 100K. You see this? Now the first number you're seeing here is 200 or 20K rather, and the last you're seeing here is 100K. So when you have plots, right, and maybe let me show you something now. The smallest graph ends at let's say 39K. So our minimum is going to be 20K, and our maximum is going to be 39K. After this, I'm going to stop sharing my screen because I believe the should be ready. 39. Let's go back to normal way so that you think you don't think that okay, oh, this is something you must do when you're plotting graphs. So I'm going to do 30, 1, 2, 3. When you plot this, you see that every single thing is reaching the top. You cannot tell which is which. Like you can't even understand this data because everything is reaching the maximum attainable height of your y limit. So now the reason why this y lim minimum and maximum is very important is so that when you have issues like this, right, you can simply just adjust them and you now see that okay, so they are not actually all the same length, but so is taller than so. So I'm going to take it back to our 100K. Then we see that we can now spot the difference. I don't know if you guys get the point I'm trying to make here. Do you guys get the point?
Yes.
All right, that's good. So Tosin, are you ready?
Yeah.
All right, I'm going to stop sharing my screen now.
Can you see my screen?
Yeah, we can see your screen now.
Good. Okay. Yeah, so I got the task and this thing. So as I was saying earlier, that C figure is sort of like a plain canvas, and you can in some cases you want to like sort of like save your image. Let's say you want to like embed the image in a report or something you are doing. So in those kind of cases, you can use something called I think plt.fig save or save feed or so. You can just make a plot.
All right, yeah, to save your plots here. Big fig.
I want to get an idea what this column is before I. Yeah, okay. Okay, since you have some sort of like values that was like range from this thing. So one thing I may want to do is in this kind of case, the value I want to put is probably like an histogram or so. I think an Instagram will work for this. So for example, I can also like do plt.hist. And I can input the value. Yeah. So this being is sort of a value that like tells how many. I'm calling process for the receipts. Sorry. Okay. Don't forget your plt dot show. Yeah. Plt dot show. So this 30 sort of like tells us how many beans we want to see. When I talk about beans, one of these bars, like the bars are joined together, so there's no easy differentiate between them. But what I mean by beans is that one of these bars that comes down like this is a bean. So that's what these beans dictate. So like something like beans and I put 50 here. You see that we get a lot of more bars and it becomes like way more complicated. If I put 10, you see that it reduces again. So that's what beans is all about. It's just like grouping your values into this thing, into like groups to be presented together. Yeah, that was beans. So let's just leave that 30 here. And it's new. So let's just say for example now to like save this particular figure, and I should have done this at the beginning to plt dot figure. So let's just figure the size of this thing, the size of the whole figure. Like I said, look at figure as a canvas. So this declares the canvas. Yeah, this plots, and this is the upper function that always make sure that you show the actual plot and everything like that. So in this kind of example, I can also do like plt dot save fig. Yeah, and if you check out parameters here, the name of this thing. So if I split like when I run this, if I check my this thing, I should have histogram.png, and I think there's a problem with this. Sorry. Okay, sorry. To sort of use say fig, you have to use the this thing, the fig and axis this thing. Sorry. DLC dot support. Yeah, something like I think it should be good now. Check it again. Oh, they see an error coming. From fig. Yeah, okay. You got it right now. So it should be fig.say fig, yeah. So that's it. Declare the figure. Like this is the blank canvas we have. So if I don't do anything, I just if I cancel this out, and I go to the should it should give me a blank canvas. So this is like the canvas, can do anything on this canvas. Now why it's giving me this box around and this label is that at this particular point I already declared axis. You get if I declare this the other way and I just do something like sorry, let me do it up here. That's something like here, plt dot figure. It just gives me a blank canvas. Yeah, plt dot figure. So like this just like shows that there's a blank canvas there with nothing on the canvas and everything. So sort of declaring the axis on it, you're going to get that particular label that there's supposed to be a particular plot in this place here. And when you are, as I said earlier, another example of how to show that our figure can be plain plot is that you can declare like multiple this thing, multiple plots in one particular figure. So an example of that would be how to declare something called n rows and n columns. So what n rows and n columns means is that it self declares. Let me just put one here. So let me just declare. Let me just show you this n rows and the other value is n columns. Yeah. So what these two values is that if I declare n rows to be like more than one, it sort of creates like remember when I told you about rows that rows goes downward in nothing about that sign. So like sort of declares multiple values. So I do this like 2 and let's also see what this will give us. See how we have like two this thing. So this is one row. This is a plot on this row and this is another plot on this row. If I add another value called n home, yeah, that's n equals 2, and let's see what we get. So, sorry, that was one I declared 2. Yeah, and you see that now we have one. This is one row, this is one row, and that row. This is one column, this is another column. So now we have like multiple axes and this kind of thing. And as usual, if we want to like index a particular this thing, what we just need to do is ask. Then now we have like a grid of this thing. So like see these plots as like a numpy array. So this is if you have a numpy array that is sort of like let me declare numpy array. So we get the index I'm using as np. And we have array is equal to np dot array 1, 2, 3, 4. Yeah. So array. Now I want to just like liken this particular array, this plot to this plot up here, these two to this particular one here, and 3 here to this particular plot here, and 4 here to this particular plot here. So as we learned on that array is that if you want to get a particular value, how do we do that? If you want to get one, it's going to be array equals to the index of the first listing here. That is 1, 0. Sorry, index of the first column. Like trying to go for 1 here. So index of the first row, sorry, comma, index of the first column, 0. So array dot 0, 0 will give us 1. Array dot 0, 1, that's first row, second column, give us 2, and so on like that. So that's the same idea I sort of like using here. And because I just like pick ax dot 0, 0 here, and here we can now plot with this thing and we do that. We see that. So there's an error here. Should plot here, not here. coming. Mhm. Hmm.
This is quite strange.
Yeah, there's an error somewhere. Let me figure out what the error is. Should have. Hmm. Mhm. Okay.
Do you want to try using the
I doubt.
implicit method?
Yeah. Okay. Okay. I think I got it here.
All right.
So I shouldn't have plotted it like equal to yet. I should have just like called it on the particular axis. So now what actually is like what's called on the particular? That's why I made a mistake. Instead of dots, I used something like this before. Look at what I mean. Yeah. So what we should have done is have like clear this out and just like plotted it directly to the axis. So this axis, the second one to axis dots 0 1 and you can do distance two. And then for that to plot from the table. What have I can plot here? Okay, let me give a back plot. Let me just put on that east, but this time for the price. Yeah, I think that's okay. Um, that's price. So you can see that this particular one has like price and something. And something I was saying earlier about giving particular axis title. I think we can do that with 0, 0. Yeah, and we can do dot title. Yeah, dot title set text equals to these lengths. And this particular one too. Just copy this and change the values for this. Don't forget, you have to like index it like a number, like you would do to a number array and a price. And when you do this, start this particular this thing. Now, if I still go ahead and put something like figure dot title, we will now have something like a general title. Remember, um, different plots, different plots. Oh, PLT title. Okay. Okay. Yeah, okay. If you appeal to the subtitle, yeah. So like this is subtitle I was talking about when it just like comes on top of everything like that. And that kind of like shows that this figure always refers to the whole canvas and each of these axes just refers to like one of those plots on their own. And now there are like different things you can also like do with this thing, with this thing, matplotlib. You can if you go to documentation, you can see the range of plots we can like kind of like plots. We can do a plot. Now this plot is like a general API for everything. So like an input, you can input whatever kind of plot you want to make. I'm coming. Let me show you this thing. So there's a parameter here where you input the type of plot you want. I think I'm going to see if I can show you from this thing. We can have plt dot plots. Yeah. We have
Wait,
something
sorry,
like type also. Yeah, go on.
before you move on with the, I mean, from the subplots, right? I'm going to show them how to make subplots using the implicit method in case they don't really
Okay,
understand this explicit. So yeah,
okay.
yeah. So let me just
Yeah.
share my screen for a few seconds.
Let me stuff here.
All right.
Hmm.
All right. So now back to the implicit method. When you want to make, I mean, this is quite compared to the previous method, right? This is, I prefer this because it is kind of seems way easier to me, right? So I'm going to come here, open this up. You just write PLT.subplot. Once you do this, it knows that okay, what I want to do now is a subplot. And then the parameters you pass into this are how many rows by column, and then the index for whatever plot it is. Let me just look at this to be sure again. Right? Let me put it in. All right. Number of rows, number of columns, and then the index. Yeah, exactly. So if I want two plots, if I want to make one plot here, one plot here, one plot here, one plot here, that's going to be 2 rows and 2 columns. But assuming I want 2 plots here, that's one over here, one over here. That's going to be 1 row and 2 columns. So to do that, I'm going to specify 1, 2. Then the index for this plot, or for the first plot rather, is going to be 1. So let me just copy all of these here now. And I also figured out what was going on with the PLT.save figure I wasn't working before. I'm going to show you guys what was wrong. These. Right. Let's see if it shows. All right, good. PLT.show. Show. Now for the next subplot, we do PLT.subplot. Sorry. Still under the same 1 row and 2 columns. This is now the second plot. So you see this 1 row, 2 columns, second plot. You're going to put this again. Or let's do, since we have our arrival time, let's do departure time. Right. So I'm going to make this PLT.list. So I'm showing data. This is the second style, so that it doesn't look like okay, this is. So you see that here we're using the dot to get it, while here we're using the normal brackets that we know to get this. All right, so everything is clustered together. So who can tell me what I should do in order to, in an attempt to separate them? Who can tell me what to do? Anyone that knows, just unmute yourself and speak.
Can we increase the size of the canvas?
Exactly. So now you have to increase the size of this canvas as this, right? We cannot do that here, but we have to do it before we even declared. We cannot do that here, and we cannot do that here. It has to be here, meaning before we declared any single thing that has to do with this entire plot. So I'll come here now and I'll do PLT dot call the figure. Want to make adjustments to the canvas. Then whatever you put here, right, is going to be for each subplot. Meaning that if I should do that, let's do that 10,7 now. The x-axis we want it to be 10. And vertically we want 7. Sorry, I'm supposed to pass all of these inside of the fig size parameter. Right. And this doesn't look very great. So let's increase this as well. Maybe reduce. No. You basically just keep adjusting till you like what you see. Now for the title of this first subplot, let's put that here. PLT dot title. This is our, this one shows our arrival time, arrivals, and this one shows our departure. We run this. We have our arrivals and our departure. I think Tosin was saying something about what was that? Is it the general title? You need to have to look into that, but when we have something like this now, arrival, departures, if we want to put a general title, we can now just put times above somewhere here. So we know that, okay, this is talking about times of arrival and times of departure, arrival and night. In this data set here now, right? When you're performing an EDA, you can tell that, okay, you for flights that are leaving the country to another, or the states or whatever to another, that's your departures. People prefer to go in the morning. You can see that people prefer morning flights over something like night flights for going. But when you're coming back, let's say you're coming back from I don't know, America to Nigeria, they don't want to see the road because you're like, we're coming back into this country again. People prefer to come back at night. So with this now, this is like a kind of letting you to understand or to know what to look out for when you're performing your EDA. So from this plot alone now, we can tell that, okay, people prefer night flights for arrivals and people prefer morning. You can see the morning and early morning, they are the highest before evening at all. So it is either morning or evening time, but people don't like midnight/afternoon flights for departure, basically. So I was going to do something here. What was that? PLT dots. I've done the title. Yeah. I wanted to show you guys what happened with the saving of a figure. So basically, when he was trying to save before, right? I believe he put the PLT dots save fig before PLT dot show. Apparently, that cancels out the function of this PLT dot fig. So you're going to do this. Shift that out. PLT dot save fig. Let's call this times. Sorry. Times the PNG. If it's not this, then it's the reverse. So I run this. There should be times the PNG here. So it's the reverse. So I'm supposed to put this before showing it. The PLT does show always has to be the last line of code that you pass when you're making VZs. So I do this and I come back here, times the PNG. You see that now we have our plots, right? As a PNG. That's the reason why we cannot see the background. You know how PNG file format appears in this kind of dotted box kind of thing. So let me make this something that is let's do .jpeg APG. What difference that makes? All right, so this is much better. This is much better. This is saved now to my PC. So if I go to the directory, right, I can see it's here, and I can do whatever I want to do with this. I can maybe send this to my boss or prepare a report with this. So this kind of work you do as a data scientist. So when you have like very, very important VZs like this, right, you can then save them and then maybe create kind of report or something and share with the rest of your team. Okay, these are my findings. So now I'm going to stop sharing my screen and send it back to Tosin. So I hope we're able to understand how to make these subplots using the implicit style. I don't know if this looks easier for you guys, but okay, let's do something now. Let's say I want one plot here. I want all my plots, instead of this being here, right, I want this to be under here, meaning that it's going to be one on top, one below. What do I write here? What's going to be my subplot shape? What am I going to do here? Who can tell?
2 by 1. 2,1.
2,1. All right, that's good. Meaning I want 2 rows of plots, but just 1 column of plots. Right now it is 1,2, meaning 1 row, 2 columns. So if I want 2 rows, 1 column, if I want 2 rows, 1, 2, and 1 column, I have to change both of them to 2,1. One cannot be 2,1 and then the other one will be 1,2. Let's see what's going to happen if you try that. See, it has just thrown away one of our plots. Meaning it's just plotting. I think it should be plotting the last one it sees. Yes, the last one. The reason why it's plotting this last one it sees, right, because let me show you something. Let's look at this now. What happens to variables when you call, or like when you overwrite? Rather, this is text. Text is equals to a oh, I'm going to print text. When I print text, I get hey, what's up? Because there's only one text, one variable called text that is available. But when I now come here, I overwrite text. I set it to, let's say, a number or another string or whatever. When I reprint this, right, what the interpreter is going to do is going to read line by line, line by line. So it has read this first line. If I was to put this print, okay, yeah, let's do that. Let's do that. Print text. This print is here now. It's going to print the first text it sees. But after printing that first text, I expect this to print the same text, right? But it's not going to do that because text has now been updated, has been made to. So look at this. You see what I'm saying? That's why when we did this right here, we've said that we want this subplot, but this subplot cannot work together because there's another subplot being called here, and it is telling them I want a totally different shape. So now to get what we actually want, what we're going to do back here, uncomment these. We make sure that the dimension, as number of rows and number of columns, is the same for both of our subplots. Now, when I run this, right, I'm going to have first row, second row, but just one column. And we can now adjust this figure size because this current size does not work for us. We can now reverse it and see we want our 15 here, we want our 7 here to look much better. Okay, no, that didn't work. On the x is okay, x. The y, let's make it 15 as well. What happens? All right, so let's now shrink our x. Our x is this, and our y is this. So let's shrink our x, make it like 9. So this goes for us. So it looks more like the size of what we had before, going on with our 1 row, 2 columns. But now we have our 2 rows, 1 column. So yeah, that's basically it. We can also have more than 2 rows, 1 column, obviously. Let's pick a third one. So I want 1, 2, 3, all of them on the same line. Someone tell me what to do. What do I do? How do I achieve that? Did you guys hear me? I want 3 subplots all on the same line. How do I do that?
1 row, 3 columns.
1,3.
Yeah.
1,3. I hope everybody is understanding what's going on here. I want it to be that I'm just explaining and people are understanding. So now this is on our 1,3. This is our first plot. This is the first plot here. The index is 1, here 2, and let's just repeat the same thing. What other thing can we plot here now? It's our third plot. Let's plot source city. Source city. All right, so yeah, it works, but we need to adjust this again. X, let's make it 15, and our Y, let's make it 8. Let's see what this looks like. It's better, but still not very good looking. So, assuming I want to make this, I want the reverse order. I want source to come first. I want departure to come second, as it is already, and I want arrivals to come last rather. So 1, 2, 3. I don't need to start shifting the position of these things. All I need to do is to come here, change this from being the last to being the first. Let's see what happens when we have two of the same index. Let's see what happens. All right, so they become we're going to go into multiple bar / histograms. We're going to look into this later, but basically they become more than one in one. So I'm going to change this now to our 3. You notice that even though arrivals is the first one we wrote, right? Arrivals appears as the last here because we have given the index of 3, which is the last position. All right, I'm done sharing for now. Oh my God, someone said they are lost. So what got you lost? What got you lost? I'm sorry, what got you lost? Yeah, you're still going to use PLT.x's name for the person asking about this. Someone said they are lost. Can you explain what got you lost? I'm waiting before Tosin takes over again. So someone is asking what is the difference between a normal plot and a subplot? Like I mentioned earlier. Okay, where's our normal plot? You see this? This is a normal plot because it stands alone. There's nothing by the side, there's nothing below it, nothing at all. Is a single plot on its own. So it is a regular plot. But a subplot means we need, what I call it, subsectors or sub. Basically, the word is subplots. Just know that we need other fractions. Yes, fractions of a majority. So this is one third. This is a sub of our 3. This is the second sub of the 3, and this is the final subset of this entire plot. You see that this is 1. It's not as if when I try and shift it, 1 is here and the remaining 3 are left, the remaining 2 are left here. So basically, this is an entire plot on its own with 3 subplots. But a regular plot has just itself, nothing else attached to it, just one plot, single. You get? Have I explained it well? You're welcome. The last 2 things you did, what are the last 2 things I did? The shifting of the position of the subplots. Is that what's confusing you, Felix? Felix, I'm waiting on you. Was that your confusion? All right, there's no response from Felix, so I'm supposed to have multiple rows and columns for it at the same time. Yes. Oh, we didn't handle that. All right, so let me show you. That. Go back to our subplots. We actually did handle that, but it's because it was just row and column wise that we plotted. So what I'm going to do is I'm going to put these 1, 2, 3 on that as well. So it's going to be 6 plots in all. How do we do that? Someone tell me. What are we going to have here? These 2, what are they going to be? Someone should mute themselves and tell me what's going to be. If I want to make 6 plots, I want these again on that. 2,3. Meaning that we want what?
2 rows and 3 columns.
All right, good.
2 rows and 3 columns. Yeah.
All right. So I'm going to update this. We have our 2,3. I'm going to copy these as well. And then update these numbers. So let's rearrange this. We have our 1, but let's leave these ones as 3, 2, 1. Then This will now be 4, 5, and 6. Let me make this source 2, rivals 2, and departures. Okay, no. Sorry. This is arrivals 2, departures 2, and source 2. So we rerun this and we see exactly perfect. So now we have a 2 rows, which is 2, 3 columns, 1, 2, 3. There's no confusion here because this is our first arrival, this is our second arrival. We put arrival 2 to be, let's count, 1, 2, 3, 4. So that's why it appears here. Let's go and check arrival 2. Arrival 2. You see the position, index, that's 4 there. 4. We put our source 2 as 6. So we count 1, 2, 3, 4, 5, 6. You see source 2. Is that clear?
Yes, it is. Yes. Please, I have another question.
What's that?
The Y limit. The Y limit. The limit is set to for like 20,000 to 100,000, but it counts by 10 or something like that. I don't understand. Like, can you make it? Can you increase like the each unit on the
Step size.
x-axis? Like, if you yeah, if you want to count it by 10,000, let's say you want to count by 20,000 instead of 10,000 on the y-axis. Sorry, do you get?
Yes. It's possible.
Okay, is it
How
possible?
you do that
Okay.
is simply by adding comma. This next comma, right, is going to be your step. So let's make this step. Let's make it 40k. 40k should work. It should be it. Now we did that for each of them again. Started from, okay, this is arrivals, the first arrivals. So we started from 20k, move the button. Let me see something. Right? Something is off. This is supposed to, I mean, we can see that it is, what's going on here? Let me confirm. This is our 3. So this is supposed to be this. Sorry, let me see something. Let me just check something. Do you know what's going wrong here? Hello, Tosin.
Yeah, I'm looking at it. Go back.
It's supposed to be a step now. Oh wait, let me check something. Sorry, plt dot xt. Okay, I was adjusting the y ticks. I think this is what I'm supposed to use instead. But let me just see.
6 is to manipulate the labeling.
The labels are
itself.
being exactly.
The labeling of each of the listing.
But look at this. I think step label. I don't know. Let's
0.2 goes 0.0, 0.2, 0.4, 0.6. That's what that one means.
so wait, Chu, let me just check something first. Let me just see something. Experimenting over here. think this one is supposed to be in bracket or something.
First two should be a tuple, then the second one should be in a separate and be named step. Put the first two as a tuple.
Okay, yeah.
Yeah, then that last one, steps, just assign steps to that last one.
You think so to be outside?
But I think I'm wrong. I'm not that it's wrong. Oh. It should be a tuple. Everything should be in the same bracket.
Start with same.
Wow. So open documentation again. That open that documentation again.
Mhm.
MP dot arrange. Oh, it expects a list or a array of what system should be like. So if you want to use step, you have to use a list comprehension or something like that.
Yes,
No, that's not just going to work. That's not going to work. A list in terms of like each of the values itself, like 20,000, 40,000, 60,000, 80,000, 100,000. Yet.
All right, let me see. I think there's a way I used to do stuff before. I shifted to C-bomb, so my plotting. I think it's with this X-Slim. I don't know. Well, I'm going to have to look over that again. I don't know why I'm not getting the desired results.
Use the code I sent to group chat.
All right, let me see that.
Just put it in this thing.
Stop presenting for them.
Or better still, I'm coming. Let me.
I can't see the code you sent to the group chat. Too.
I'm coming.
All right.
I'll probably send your DM now.
All right. Are you doing the list comprehension format?
Yeah.
All right. Well, there should be a way. Well, I'm going to look into that to get the. I'm very sure I've done this before several.
Have you seen it?
Let me check that now. All right. Let's.
Your screen is not shared, though.
Yeah. I'm about to start sharing again. So basically, this format I'm about to show you guys something called list comprehension, and how you build this is what you do. Yeah. Now I'm going to do for I in the range of 20K, 20 to 3, 20,000 to 1,000, 300,000. But this is going to end with 1 because if we do right, if you write 100,000 right, it's going to give us 999 values. But when we do 101,000, it will now give us 100,000 values, and you place the step, which is 20k for this part. This part, right, is the regular loop. This x. This is a regular loop that you know. So basically, for this in this. Now, what I'm going to put before the loop is the same as what we're going to is the same as what happens when you write this.
You not put x before x for
yeah,
x.
I'm
Not...
aware.
Okay.
I'm aware. I'm explaining the stuff to them. So basically, right, this is for x in range from 20,000 to 100,000 with a step of 20,000, meaning 20,000, 40,000, 80,000, blah blah blah. Return x. Now this return is what you put before the entire for loop when it comes to list comprehension. So this right now is complete. What we're going to have is going to give us values 20, 40k, 60k, 80k till it reaches 100k. So let's comment this out and we run our code. Our white ticks are going to be updated just how we want them to be. So do you see that? Yes, this is what we've just done now is what is called list comprehension. There's list comprehension, there's dictionary comprehension. There are different types of comprehensions you can do. So you can still look into that to, you know, find out what other amazing things you can do. But I'm still going to look into this while format because I know I've done something like this before. But yeah, Tosin, you can take over from, you know, you can stop presenting.
Okay, I think we've covered most of what was like cover in terms of like raw marketing code. I think the basics you need to know. Maybe one other thing you want to like know is like
Color maps.
it.
Let
me show people that I'm trying to get. Sorry.
Another thing we need to look into is color maps. You know,
for
those of you who like being creative, you can't have these plots that you're seeing so far. They've been boring, just the regular blue color, the blue default that comes with matplotlib. But you can have your plots with various kinds of colors mixed together. So you can also show them the color maps right now to see.
Okay. So the color maps just use a simple CMap function, I think. And I'm going to say if CMap, let me just do a backplot with it. Same for something. Okay. Source setting. So we have, let me just give this example. Figure comma. I'm going to use the other formats now. PLT to PLT dot subplots. Okay. Then I'm going to do ax dot plots, or let me say bar. Yeah. Ax dot plot bar. I'm just going to put. Yeah. Okay. What's the best way to go about this? Okay, let me just do it counts. Data dot sourcity dot value counts. Yep. Yeah, okay. I think there's a this is good. So I can just do this dot index. Yeah, comma. I think this should work. Yeah, okay, it works. It works. So we have this. So also another thing I've not mentioned earlier, another substitution for PLT.imshow is just a simple semicolon and you're good. Just put at the end. So you don't have to put PLT.imshow. I did that. It showed me what I needed this to show me. But I'm coming. Let me go. CMap. I think CMap should be a value here. Okay. Yeah. So coming. Red. Yellow, green. Will this work?
Try blues or RGB. Try RGB BGR blues.
No, I don't think the problem is coming from that. I think this particular one does not have that.
Okay, no, try and pass it
Wait.
as. Okay, sorry.
Matplotlib. Okay. Mm-hmm. I'm trying to look for a solid or simple example they used it. Mm-hmm. They are just plotting the this in themselves. They're not using them here. Yeah. Good. Okay, it should be color. Yeah, I think that's where we missed it. It should be color.
Yeah, try color or C, and also specify the size S. Just
yeah, it should be color. Let me try that. Color. Yeah, let's put this. Yeah, okay. I think I can't use CMap with Xos bar. I can't use CMap with Xos bar. I think
try
CMap
dot scatter. Let's see.
the scatter. CMap would not work for the scatter. What to work? I'm thinking of where to work. It should work for this. I can't seem to like get wrap my head around it now. But CMap sort of like kind of like differentiates. I think I'll look up the code after and I'll send it down to people. This green, this one just like changes the color. But what CMap should do is that it should give the like different columns and colors. So this one can be green, this one can be blue, this one can be red, this one can be gray, this one can be black, this one can be
try
another color.
try specify hue, right? Put the C map, the whatever.
Hue will work on this thing. Hue would work on separating that set, but you not necessarily show what the schema is. Like so you not necessarily show like that's an idea of CMap of differentiating this thing.
Yeah, I get. I feel you. I was thinking maybe if you pass the two of them together, then you can say, okay, I want a hue, and then I want the color map for that hue, that specific hue to be whatever. Do you get
it? I'm coming. Okay, let me try that. Let me see. Okay, this is first. Then we start charging with CMap, right? And
yeah. What's this showing?
Nah, it's just to give him.
No, you use the values.count index. Is it supposed to be the index or the key?
I'm coming for something. I'll use arrival time as the issue.
All right.
Can arrival time work as you? Yes, arrival time should work as you. Yeah. I don't think you can. I don't particularly know how to use this queue and CMap on bar. I will check that later and send to you people.
Yeah, we'll get back to
But
you guys on.
what thing I wanted to show you with this is that we can sort of like do something like I'm getting the bars. I think I don't know what to say. I'm getting the bars with X for so like for patches. Or let me say patch in Exos patches here. And yeah, this is good. Let's to complete this for me. So what this does is that sort of like gets the values and kind of like M plus it. So you see. So you see that each of the values for each of them are sort of like on top of them, on top of each other, and like that. So that this particular code, I'm coming. Let me break it down so I'll explain it to people. Yeah. Mm-hmm. Yeah. Mm-hmm. So what this does is I'm coming. So like indents in the session. What this patch means is it represents this kind of cases that it represents one of those bar and ask those batches is used to like just like single out each of the bars in a particular plot. I think you can use x dot ask dot patches for histograms and you can also use them for bar charts. You get since those kind of like this thing have bar kind of like plots that have like bars with them. So it picks one of them and then this ask dot annotate sort of like gives an annotation to them. Then what it does is that if you look at the documentation for this, yeah, okay, text your string, then this string is what is going to be annotated with. So if you sort of like look for, let me do something here. Let me just kind of print for us just print string patch to get height. So get height is sort of like the value, the height from top here, the way it is here, sort of like the value of the bar chart itself. You get since it's like counting how many it is, so like tells us that from this bar represents that we have about 6,343, which in this particular case is also the height of the bar in this thing. So we can just get that value by simply calling the get height function on that particular patch. So if I do this, I'm sorry. If I do this, we should have this thing. So you see that for each of the patches, printed them separately. So this gets the value that is put up here. This particular one here sounds like it gets the location of where it should be, like here's a plot sort of here. So it gets the kind of like x and y coordinates of where that particular this thing should where that particular this particular number we got up here should go. This kind of like puts it in center. So if I remove this, let me remove this.
In case you're trying to talk to, so your mic is muted.
Sorry, can I quickly ask? Um, can I quickly ask something before
Yeah,
you get
sure.
back? Okay, that AX dot bar, the first two values that I passed within it, what do they represent? Okay, I know the data count gets the like number of flights that arrived in Mumbai and stuff like that, but the dot index part, what does it represent?
So it's the next thing on the call.
Yes, yes, yes. Oh, no, not me.
Because I personally use the implicit style. I don't use the explicit, so can't really answer that question. Just have to.
Oh,
Let me
okay,
try
okay.
to get my CFUs. All right. All right, it's currently, I think maybe his router died because he's also not online on WhatsApp. So you can send your question to his DM and he'll reply you when he comes online.
Oh,
Yeah,
okay.
yeah.
Okay.
So I'm still looking into that white ticks and why we couldn't achieve it through that method. Just trying to be very sure of something.
I wanted Papa there.
So still not working. It's going to be this for now. All right, so let me share my own screen and you guys can ask any questions you have or anything that you were wondering while I was coding. You can just ask. This list comprehension stuff, was it confusing to any of you? Like what went down here? Was it confusing when we did this? Is this confusing to anybody? Can you guys hear me?
I understood it actually.
You
Yes,
understood it?
yes, yes. It was okay. Yes.
All right.
Sorry, wanted to ask. Sorry, can you quickly differentiate between a list and a tuple? I think I was not paying
All right.
attention when you mentioned that.
Look at something. List. Sorry, our list equals to our tuple equals to. What difference can you spot between these two first, like on a topical level, on a surface level? What difference can you spot?
Square brackets, and normal brackets.
Good. Now, do you also know what a set is? A set or a dictionary? It's basically sets, dictionaries. Do you know what they are?
Yes. Yeah, I've heard of dictionaries. When you assign one key to like key variable pair or key value pair, something like
Yeah,
that.
exactly. So basically, this sign represents a set, and it can also represent a dictionary. It depends on what you pass into it. So if I pass in something like this now, remember when we're building our when we're trying to make a data frame from scratch, we did something like this. So this right now is not a set, but a dictionary. But if this is a set, let me go back to the explanation of what's the difference between a set and to join. Was that too soon? All right, back here. Basically, we have this list. We have a list of 1, 2, 3, 4, 5. We have a tuple of 1, 2, 3, 4, 5. A list, right, can be updated. Meaning that if I want to add a new number to this list, I can add a new number. If I want to replace this 2 now with something else, I can replace this with something else. If I want to even empty this list, I can empty it. But for a tuple, once you declare a tuple and you pass in variables, it can never be updated. Like there's nothing else you can do. You can only just look through it, do whatever kind of anything that does not have to do with changing these. Look at this now. Let's say I do for number in range. Let's do from 10 to 20. Now I want to put these numbers into our list. Our list dot append. We do this number. When we run that, we now print our new list. Print.
You made a mistake. Change is 1010 instead of 1020.
Imagine. Thank you very much. So we not put any step, as we not put automatically when we don't put any step, right? This is equals to 1. But if I had done 2 now, we're going to get 10, 12, whatever. Right, look at this. We have our 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's the original list. Plus the appended values. That's 10 to 18. The reason why we didn't get 20 is because when you're dealing with range, you have to start from whatever value you start from is what you get. But whatever value you place as your end, you get -1 of that. Now we have our 20 here. Basically, our list has been updated because it can be updated. But if I had done something like our tuple, right? It does not even have this append function. There's nothing such as append. There's even if you try and look, maybe there's another English they use for the whatever, right? Let's say you try and look through the operations. You are seeing that it's only you can only get the count, index, and some other information from it. But if you come to our list dot, see we can append, we can insert, we can remove, we can extend, we can sort. I think we can also sort. Do you know it's not possible to sort tuple? But basically, right, a list you can perform several kinds of operations. Let's also do this insert now. When you're performing an insert operation on a list, right, you have to pass in the index and the new value. So dot insert here value they want to insert and the support index. All right, so I want to pass into 3 and the index is 0. So when I do that now, export a new list. So I've updated for us. We're going to check something first.
I think because you typed index instead of insert.
Wonderful. Very much. I think we need this. Right. So what it did was I inserted. Okay, you're supposed to pass the 0, 1, 2, 3. So basically, the first value here, right, is the index, meaning where we want the value to be put into, and then this here is what we want to put into that place. Let's say I do this now. I change this from I want the index to be -1, meaning make the last value, or add another value to the end. -1, 0. All right. So what it did, right? This was our previous list, and the last position, the -1 position before was 0, 1, 2, 3, 4. So what it has done is it has gone to 0, 1, 2, 3, 4, and it has put 0 for us at the previous last position, at the previous index of last position. So
is last position not supposed to be 5?
yeah, it's supposed to be
Why
5,
is
right?
it? Why is it?
But basically, what
Yeah.
happened here is that it looks at the list. The first index is 0, second index 1, 2, 3, 4, right? For the current list. So you now went to this position of the previous last index and put in our new value to the previous last index. So now the new list, right? This is still 4, which was the last index of the previous list. But now that last of this new list has shifted. Let's try and put another value now. You see that value will come here. Let's do that. Let's just rerun this. Basically, you see that it has just shifted. It's just continue shifting it based on the previous list.
Oh, okay.
Okay. So
There was something you did with the plots, and I think I understand the list and tuples now. Thank you. Now something you
all
did
right.
with the plots instead of writing PLT.zao plot. Like he called variables and he assigned it to the PLT.zao plots.
Yeah, that's what I was saying at the very beginning of our lecture today. There are two different styles of making plots um with pie plots. There's the implicit and the explicit. So the explicit creates figures and axes for you, and you can call those methods. You can call several methods on them. You see this now, figure, comma, axis. This is the explicit version or the explicit style or method of working with matplotlib and pyplot. But the implicit, it takes care of all of these for you. Automatically, we already have our figure and our axis. When we sorry, let's clear my throat. All right, so basically, when we use the implicit style, it takes care of these for us. We don't need to start worrying about assigning variables to our subplot object and then having to call those fig or ax or whatever later on. We just use our implicit style and it does everything for us automatically. PLT dot this, PLT dot that, PLT dot whatever you need to achieve. You get, so there are two different styles of working with pyplots. Is that you're working with the implicit method or the explicit method? Simple. I hope that's clear.
Okay. Yeah. But the table for the data, I'll be the .csv file.
Yeah.
How does using the explicit style, how do you know that is that file that we're referring to? Like, how do you know that you want to read the data file?
Are you seeing this right here? We imported
Yes, I
pandas
can see it.
and we read in the data from
Yes.
wherever it is, which is currently our present working directory. Basically, right? This putting a full stop at the beginning of this is the same thing as not having a full stop there. When you put a full stop, it tells you, what's going on. Okay, let's do this first. This is supposed to be a directory. Come on. Right. So basically, right, this is the same as this. What that means is inside of this current working directory, search for the file called flight data.csv. But the reason why you don't have to pass in that dot and slash, right, when the information is already in our directory is because this is our root folder. Now, whatever you're looking for, you just have to put the name down. It's going to search within the same file or the same location where this current file is. So hence they are both in the same directory or folder, whatever you want to call it, right? You just pass in the name and you just check, okay, within this same name, can I find this flight underscore data.csv? If you can find it, then it's return it to you. If you cannot find it, it will throw an error saying no such file or directory. So you not have to look into this and say, okay, well, maybe there was a typographical error, or I'm not searching within the correct folder. So that's just it. Okay.
Okay. So once you read it at the top, even if you use figure and access the explicit whatever, okay, yeah, you see that you wrote plt.hist, then into brackets, then you now call data, then you put departure time and all. Why is it not the same for the explicit what do you call it now? Why is it not the same? Like you're not referring in that explicit style or method, you're not referring to the database at all. That's what I'm asking.
No, he was
Because you don't want
actually, he was. Do you remember
sir?
at the beginning when he was trying to like when he even had to stop sharing his screen for a while, then I took over. He was searching for where he put this file and he was trying to place it in the same directory. He was trying to put it in the same place. He wanted the two of them to be in the same place so that he can just simply call it. Then what he did was that he just
Yes,
called it
yes.
and then skip straight forward to the rest of this for you guys. So you didn't really see this part. All you saw was just from maybe wherever he started from, and that was all you saw. But I don't know if you saw when he was even doing this data and then departure time. That is to tell you that, okay, well, he has called the data set and he has assigned it into the variable called data.
Okay. Okay.
Yeah.
Yeah. Thank you.
So, do we have any other questions? If we don't have any other questions, I'm going to be telling you guys what we'll be doing, what we'll be covering next week. Next week, we're going to be starting a project basically with this same data set that we're familiar with. We're going to be trying to predict the prices of tickets considering all these independent variables. So, like I mentioned last class, these are independent, these are dependent. We're going to walk through the workflow of an entire project essentially. So we're going to go from reading the data set to checking for anomalies in our data, cleaning those anomalies, preparing our data sets for be fit to an algorithm, which is the process of training our model. So when you fit an algorithm to a data, you're telling the algorithm, look at these, learn from these, and then from there we're also looking into predicting outputs with our model. So we can now pass in stuff like SpiceJet, blah 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 into our model, and it tells us, okay, so the price that you're getting you should be looking at 50k upwards, or 5k upwards rather. You should be looking at 5k upwards based on whatever we pass in. So we're going to be looking at training a model and testing. Like we're going to be looking at our model accuracy and basically how to improve your model. So just get ready because we're diving into the main AI right now. That's what we're going to be doing starting from our next class. So if we've not signed the attendance, remember to sign the attendance. If you have, prepare your mind for next class because it's going to be quite interesting. So that'll be all for today. Thank you guys for coming. I'll see you again in our next class. Yeah, I'm going to zip this file and send it to you guys as well so you can look at my version. I'm going to tell I'm also going to correct any of these errors here, so fix this before sending it to you guys. Also going to tell Tosin to send in his own so that you guys can look into what we've done today. Yeah, so that'll be all for today. See you guys on Monday. Have a great weekend. It is called regression because we'll be predicting continuous values. That is, anything that is number is a once you are predicting number and those numbers don't stand for, okay, well, let's say number 1 is supposed to stand for boy, number 2 is supposed to stand for girl, or number 2 is supposed to stand for boy, number 2 is supposed to stand for boy, number 1 is supposed to stand for girl, whatever, as long as the labels, right, are not for, okay, this is this and this is that. That is not, and anyone that has to do with labeling data, like definite answer. If it's not this is that, or if it is not this or this it is that, that's a classification task. But regression is when you're trying to predict continuous values. That's numbers. It can be prices of a house, it can be price of clothes, it can be what else, any kind of continuous value you can think of. Just numbers. Anything numbers is regression. Anything that numbers that does not stand for a class, regression, you get. So that's good. See you guys next class. I'll be sending in the zipped file of what we did today, so you guys can unzip that and look into it, and just text on the group chat, and you can tag Tosin or I if you have any questions regarding what I'm going to send to you guys. In case you send me a text on my DM and I've not replied, it's probably because I've been extremely busy trying to learn new stuff and work on projects. So you guys should listen. Once we're done from next class, you guys should start building your project. Like, you start working on projects, having errors, finding out how to solve those errors. And yeah, I look forward to the next class for you guys. Have a great evening and much better weekend. Goodbye.